1. Elimination method. 2. Substitution method. 3. Graphical method. 4. Matrix method. And 5. Using grammar. Let us solve them one by one, starting from elimination method. Let's pick number 1. Question number 1 is x plus y is equal to 5 and x minus y is equal to 1. We can decide to call the first one equation 1 and call this equation 2. Remember, that is called simultaneous equation because we solved two unknown at the same time. Unlike linear equation, here we are solving for x and y at the same time. And because we have two letters to solve at the same time, hence the word simultaneous, we have two equations. One of them called equation 1 and the other equation 2. We are going to start today's work with elimination method. What do we mean by this elimination method? In elimination method, we try to remove one of the unknowns. We may remove x first or remove y to solve the other. We solve them one after the other. That's the meaning of what? Elimination. Let us go on to eliminate it. If we add equation 1 and equation 2 now, it will eliminate 1. If we subtract equation 2 from equation 1, equation 1 from equation 2, we eliminate x. Let us eliminate y by addition. Adding this will give us 2x. Adding will give us 0. Y plus y minus y will give us 0. And adding 5 to 1 will give us 6. And so we have only the coefficient to use and divide both sides. I hope you understand. X plus x is 2x. Y plus minus y is 0. So we have only 2x is equal to 0, is equal to 6. Divide two sides with the coefficient of unknown, giving us, dividing by 2, giving us x alone is equal to 3. So our first equation, the first answer is that x is equal to 3. Assuming we don't want to solve by substitution at all, we just want to eliminate, only elimination, then let us pick the same equations. X plus y is equal to 5 and x minus y is equal to 1. Now, this remains equation 1 and this equation 2. Let us eliminate x in order to solve for y. Since we have gotten x now, we can eliminate the same x so that y will remain in the equation for us to solve it. Then, what it means is that we are going to subtract for us to eliminate x. Remember, what we want to eliminate must have equal coefficient. Coefficient 1, coefficient 1, coefficient 1, coefficient 1. Whether it's plus or minus, we are interested in that number 1. Then we are going to say y minus y will give us 0. Even if we write 0, we cancel it out. Y minus y will give us y plus y, and that is y having 2y is equal to 5 minus 1 will give us 4. Y 2y over 2 is equal to 4 over 2, giving us that y is equal to 2. Therefore, we can conclude from our calculation so far that x is equal to 3, while y is equal to 2. So in this simultaneous equation, x plus y is equal to 5 and x minus y is equal to 1. We can see that the value that will make it true is when x is 3 and y is 2. Let us check. In case we are in doubt whether this is going to be true, let us check from the equation there. Lift x here, put where we have 3, substitute it for x. Substitute y with 2 there. 3 plus 2 will give us 5. 3 minus 2 will give us 1. But this is the solution of it using elimination method. Hope that is clear. Is that right? Now, assuming when we stop at this point and we wish to replace 2, place number 3 where we see x in any of the equations, we can still get the other one, which is y. But here we have used what? Only elimination method. I hope that is clear. Thank you very much. Now, we go to number 2. Remember, in whichever one you are going to solve, we need equal coefficients. Here we have equal coefficient 1 and 1, equal coefficient 1 and 1, whether it is plus or minus. Let's go to number 2. Do we have equal coefficient in number 2? In number 2 we have 2 and 3. All right, we have 1 and 1. So here we can eliminate y to solve x. Let us solve for number 2. In our number 2, we have 2x minus y is equal to 8, and 3x minus y is equal to 17. Let us see the values of x and y that will make these equations true, so that the left-hand side and the right-hand side will be equal. That means we wish to make this one, call it equation 1, just to be able to refer to them, and call this equation 2, just to be able to refer to them too. Do we have equal coefficient here? No. Therefore, we cannot eliminate x. But since we can eliminate y, we have no problem. When we have two signs, different signs, we add. When we have signs, the same sign, we subtract. So we are going to subtract to be able to eliminate. What do we have to subtract? Either you say equation 1 minus equation 2, or equation 2 minus equation 1, whichever one you like, whichever one you want to use. However, this is my determinant. Since in equation 2 we have a bigger number, in equation 2 we have a bigger number than equation 1. Let us say equation 1 minus 2. If we say so, we are going to get negative sign. If we say equation 2 minus equation 1, we are going to get positive signs. I believe many people will like us to use positive signs. So let us say equation 2 minus equations 2 minus 1. That means 3x minus 2x will give us only x. Minus y minus y will give us 0. I hope you understand that. That's minus y minus y. Where are they coming from? Minus y is from equation 1. This minus, that's what we have here. And minus y is 1 inside the bracket. That means we are going to have minus y plus y. And of course you know that minus 1 plus y or plus y minus y will give us 0. And so that is how it becomes eliminated. And we have that this is equal to 17 minus 8. That will give us 9. So in this calculation, x is equal to 9. Because we don't have equal coefficient in x, we may decide to replace x with 9 in any equation of our choice. So we can say, right, substitute 9 for x in equation 1. Whether you choose equation 1 or x or equation 2, you are going to get the same results. So let us choose equation 1. That will give us, equation 1 says 2x minus y is equal to 8. Anywhere we see x, we replace it with 9. And so 2 times 9 minus y is equal to 8. 2 times 9 will give us 18. 18 minus y is equal to 8. Then we are collecting like terms as usual, meaning that the number 18, we go to that side, we have minus y is equal to 8 minus 18. In that sense, minus y is equal to minus 10. Can you see that it's minus 10? Yes. If it's minus 10, we leave it like that, unless we have the unknown having the coefficient of plus 1, an index of plus 1. We will not leave it like that. So we have to divide both sides by minus 1, the coefficient of the unknown. That will give us y being equal to 10. Therefore, from this calculation, we have seen that x is equal to 9 and y is equal to 10 as the correct answers. How that is understood? All right. Remember, we are able to solve this because we have equal coefficient in y. We decided not to eliminate x because we don't have equal coefficient. Not that we cannot force it to have equal coefficient, but that is going to be done in another class. And that is when we are going to form equation 3 and equation 4. All right, let's go to equation number 3. Equation number 3 also have equal coefficient in 1 and does not have equal coefficient in another. We have equal coefficient in A and there is no equal coefficient in B. Let us try that. That question actually gives us the number 3. 2a plus 3b is equal to 10. And 2a plus b is equal to 2. As usual, we are going to call the first one equation 1 and call the second one equation 2. And then try to solve them simultaneously at the same time using elimination. The equal coefficient here will help us to eliminate it. Class, what is the sign of this 2a? What is the sign of this 2a? In each case, it is plus 2. Because of that, we are going to subtract. Let us take away. And it's a good thing that equation 1 has more number than equation 2. So let us subtract directly and say 2a minus 2a will give us 0. We may not need to write it. 3b minus b will give us 2b. And that is equal to 10 minus 2 will give us 8. So this is what we will get when we have completely eliminated A. We are solving for B now. Divide both sides by the coefficient of B will give us 2b over 2 being equal to 8 over 2. And that will lead to cancellation of 2 for us to have B on the left hand side being equal to 4. So in this case, B is equal to 4. If B is equal to 4, anywhere we see B in any equation of our choice, A, equation 1 or equation 2, let us put 4 to be able to get what is the value of A. So we are going to write substitute 4 for B in equation 2. This time around, let us choose equation 2. Remember, you can choose any of them. And then we have this as 2a plus b is equal to 2. We have seen b where b is here. So 2a will still remain 2a. 2a plus, remember our b is 4, plus 4 is equal to 2. Again, correct like terms because we see 4 here, we see 2 here. They are numbers without letter. We are going to have 2a is equal to 2 minus 4 will give us minus 2. Meaning that we have 2a over 2 is equal to minus 2 over 2, which means a is equal to minus 1. Therefore, our answers will now be a is equal to minus 1 and b is equal to 4. If we lift the numbers up here and put minus 1 where we see a, 4 when we see b, what we are going to get on this left hand side will, of course, give us 10. The same thing is applicable to equation number 2. And so in this question number 3, a is equal to 1 minus 1 and b is equal to 4. Yes, I would like you to solve question number 4 and tell me in the comment section what is going to be the answer. Of course, you can see that we don't have equal coefficients in any of them. I would like a situation where you can solve it, compare it with what we have done in equation number 1, 2, and 3 to get the values of x and y, which are the unknown. See you in another.